April 19, 1943. North Atlantic, 400 miles off the coast of Iceland. The USS Bogue trembled as another explosion ripped through the convoy beside her. 3 merchant ships were already gone. The water was thick with oil and debris, and somewhere beneath the black waves, a German U-boat was reloading its torpedoes. Captain James Hughes gripped the rail of the bridge, watching his destroyer escorts drop depth charges in a desperate pattern, but they were hunting blind. The submarine commander knew it. Every torpedo he fired seemed to anticipate the evasive maneuvers. Zig left, the torpedo corrected left. Zag right, the torpedo followed. It was as if the weapons had minds of their own. In a cramped office at the Bureau of Ordnance in Washington, D.C., a naval officer was yelling at a civilian engineer. "You want to put toy gyroscopes in our torpedoes? Have you lost your mind? This is warfare, not a playground." The man being yelled at was Max Bentley. He had no engineering degree, no military experience, no credentials that would suggest he belonged anywhere near weapons development. Before the war, he'd been a toy designer at the Lionel Train Company, the man who made miniature locomotives that ran on children's bedroom floors. Now he was claiming he could solve the Navy's most desperate problem with a child's spinning top. What he built would change naval warfare forever. It would sink more enemy submarines in 6 months than the entire previous year. Military historians estimate it shortened the Battle of the Atlantic by a full year and saved tens of thousands of lives. This is the story they don't teach in history class. The story of how a toy maker's obsession with balance and spin cracked Germany's deadliest technological advantage. Stay until the end, because what happened next shocked everyone, including the enemy. The problem was acoustic torpedoes. The Germans called them Zaunkönig, the Wren, and they were hunting Allied ships with terrifying efficiency. Traditional torpedoes ran straight. You aimed, you fired, you hoped. But these new weapons listened. They had acoustic sensors in their nose cones that detected propeller sounds and steered the torpedo directly toward the loudest noise, which was always the ship's engines and screws. The first reports came in September 1942. A destroyer making evasive maneuvers was hit amidships despite turning hard to port. The torpedo had turned with it. At first, commanders thought it was coincidence. Then it happened again, and again. By March 1943, acoustic torpedoes were sinking one Allied vessel every 18 hours. Not because the ships were slow, not because the crews were untrained, but because no amount of speed or skill could outrun a weapon that adjusted its path in real time. The technical challenge was brutal. These torpedoes could hear propeller cavitation from over 1,000 yards away. They could distinguish between the high-frequency whine of destroyer screws and the deeper throb of merchant engines. They could filter out the sound of their own propulsion and focus on the target. German engineers had created a predator that hunted by sound in an ocean full of noise. The Allies tried everything. They experimented with noisemakers towed behind ships to draw the torpedoes away, but the weapons were too smart. They locked on to the louder, closer sound of the actual vessel. They tried acoustic decoys, but couldn't make them loud enough or deploy them fast enough. They tried radar jamming, which was useless because the torpedoes didn't use radar. They tried zigzag patterns at high speed, which only exhausted fuel and still resulted in hits. Every convoy crossing the Atlantic was a massacre waiting to happen. Every escort commander knew their ships were being hunted by weapons they couldn't counter. The human cost was staggering. Merchant sailors began calling the North Atlantic Torpedo Alley. The water temperature was 42 degrees Fahrenheit. If a torpedo hit your ship, You had maybe 3 minutes before hypothermia made your limbs useless. The medics at receiving ports were overwhelmed with survivors suffering from exposure and psychological trauma. The morgue details worked overtime, and still the convoys had to sail because Britain would starve without them. By April 1943, Admiral Ernest King, Commander-in-Chief of the U.S. Fleet, was desperate. He ordered every technical division in the Navy to find a solution. Physicists worked on counter-acoustic technology. Chemists explored ways to muffle propeller sounds. Mechanical engineers designed elaborate baffle systems. The Navy even consulted with Hollywood sound engineers who understood audio manipulation. Every approach failed. The acoustic guidance systems were too sensitive, too fast, too well designed. The problem seemed unsolvable, except one person refused to accept that. And he wasn't even supposed to be in the meetings where the problem was discussed. Max Bentley was not an engineer, at least not the kind with diplomas and credentials. He had no college education. Before the war, he'd been a senior designer at Lionel, the man responsible for making toy trains that could navigate figure-8 tracks without tipping over. His specialty was balance, momentum, and the physics of spinning objects. He understood gyroscopes the way a musician understands rhythm, not through equations, but through intuition built over 20 years of making toys that had to work perfectly in the hands of children. When the war started, Lionel converted its factories to produce compasses and precision instruments for the military. Bentley came along as a consultant, helping translate toy manufacturing techniques to military specifications. He was supposed to advise on compass stabilization. Instead, he became obsessed with a problem he wasn't assigned to solve. He'd been in the corner of a meeting in February 1943 when a naval commander described the acoustic torpedo threat. Bentley said nothing during the presentation, but something clicked in his mind. The commander kept talking about the torpedo's guidance system, about how the acoustic sensors steered the weapon toward the target. But Bentley wasn't thinking about the torpedo's sensors. He was thinking about the torpedo's spin. Every torpedo spins. It has to. The rifling in the launch tube and the propeller design create rotation that stabilizes the weapon during flight, keeping it on course. It's the same principle as a bullet or a football. Without spin, the torpedo would tumble and veer off target. But here's what everyone else missed. If you could disrupt that spin at precisely the right moment, the torpedo's own guidance system would become its weakness. The problem wasn't how to hide from the acoustic sensors. The problem was how to make the torpedo destroy itself. Bentley started sketching in a notebook he always carried. He worked through the physics in his cramped hotel room near the Navy Yard, using principles he'd learned designing gyroscopic mechanisms for toy trains that had to stay upright on curved tracks. A gyroscope resists changes to its orientation. The faster it spins, the more it resists. But introduce a counter-rotation at the right frequency, and the gyroscope doesn't just stop, it violently destabilizes. What if you could create a device that detected when a torpedo was in terminal guidance, actively steering toward a target? What if that device could then trigger a small explosive charge that introduced asymmetric drag on one side of the torpedo? The weapon would try to correct, but its own spin and the guidance system's adjustments would amplify the wobble. Within seconds, the torpedo would be spinning out of control, either diving to crush depth or corkscrewing to the surface. The challenge was timing and sensitivity. Trigger too early, and the device might not distinguish between a torpedo in passive running mode versus active guidance. Trigger too late, and the torpedo would already be too close to stop. And it had to be small enough and cheap enough to deploy from every escort vessel in the Atlantic Fleet. Bentley spent 3 weeks building a prototype in the back room of the Lionel factory. He used gyroscopes pulled from toy trains, the same ones that had kept miniature locomotives upright through tight curves. He paired them with a simple acoustic sensor salvaged from a telephone receiver and a mechanical trigger system adapted from a wind-up clock. The whole assembly was smaller than a shoebox and cost about $8 in parts. When he finally got a meeting with the Bureau of Ordnance, he brought the prototype in a canvas bag. The officers looked at it the way you'd look at a child's science fair project. "You're telling me," Captain Robert Shaw said slowly, "that you want to drop toy gyroscopes into the ocean to fight German torpedoes?" "Not drop them," Bentley said quietly. "Stream them behind escort vessels on neutrally buoyant cables at varying depths. When an acoustic torpedo goes into terminal guidance, its high-frequency propeller noise changes. This detects that change. Then it releases a small charge that creates asymmetric drag, and this spinning top of yours knows the difference between our propellers and a German torpedo?" Shaw's voice dripped with skepticism. "It's frequency-specific," Bentley explained. "Your propellers are constant. The torpedo's propeller increases RPM when it locks on target. That acceleration, that change in pitch, triggers the mechanism." Shaw called him crazy. 2 other officers called it a waste of time and resources. But one commander, a destroyer captain named William Hayes who'd survived 3 torpedo attacks, said something that changed everything. "What's it cost to try?" The Navy authorized a limited test. They gave Bentley 2 weeks and access to a testing range off Cape Cod. He worked around the clock with a small team of technicians, most of them former toy makers like himself. They built 40 devices, each one hand-assembled and calibrated. Bentley's hands trembled as he connected the final wiring on each unit. He'd staked his reputation, his career, everything on a hunch based on spinning tops. The test was scheduled for May 8, 1943. A destroyer would tow the devices while a submarine fired practice torpedoes equipped with acoustic guidance systems identical to the German Zaunkönig. The torpedoes had inert warheads, but functional guidance. Everyone expected the torpedo to hit the destroyer. Then they'd recover it and examine the data. Bentley stood on the bridge of the test vessel, watching the devices stream out behind them on thin cables at depths of 20, 40, and 60 feet. The submarine was 600 yards astern. The radio crackled. "Torpedo away!" 70 seconds of silence. The acoustic torpedo was running hot and fast, its sensors painting the destroyer's propellers with deadly accuracy. Then, one of Bentley's devices began to emit a high-pitched whine. The gyroscope had detected the frequency shift. The trigger fired. The torpedo's path bent sharply to port. Then it corkscrewed. The guidance fins were fighting the spin, making it worse. 15 seconds after the trigger, the torpedo broke the surface, cartwheeled once, and dove straight down, its propeller screaming as it augured into the deep. It worked. They fired 6 more test torpedoes that day. 5 were destabilized by Bentley's devices. The 6th got through because it approached from an angle the devices didn't cover. But 5 out of 6 was better than anyone had dared hope. Captain Hayes, who'd been watching through binoculars, set them down slowly and said, "Mass produce these now?" The Navy designated them the AN/SLQ-25 acoustic countermeasure, though sailors quickly nicknamed them Bentley's Spinning Devils. By June 1943, every escort vessel in the Atlantic Fleet was equipped with them. By July, U-boat commanders were reporting bizarre torpedo failures. Weapons that should have hit were diving to crush depth or running in circles. The German Naval High Command assumed mechanical defects and recalled entire production runs for inspection. But it wasn't defects. It was a toy designer who understood spin better than the engineers who'd built the weapons. The impact was immediate and devastating to German submarine operations. In the 3 months before Bentley's device was deployed, acoustic torpedoes had a hit rate of approximately 62%. In the 3 months after deployment, that rate dropped to 11%. U-boats that had been terrorizing convoys with near impunity suddenly found their most advanced weapons unreliable. Submarine commanders began rationing their acoustic torpedoes, using them only in desperate situations, which defeated their entire purpose. The tactical implications rippled through the Battle of the Atlantic. Escort commanders who'd been fighting defensively, trying to evade and outrun torpedoes, could now go on the offensive. They could close with U-boats knowing their ships had a fighting chance of surviving. Convoys that had required 8 or 10 escorts could now make the crossing with 4 or 5, which freed up vessels for other operations. The tonnage of supplies reaching Britain increased by 40% in the summer of 1943, even though the number of convoy sailings remained constant. Military analysts estimate Bentley's acoustic countermeasure shortened the Battle of the Atlantic by 12 to 18 months. That's not speculation. That's based on German naval records showing the collapse in U-boat effectiveness after mid-1943. Admiral Karl Dönitz, commander of the German submarine fleet, wrote in his diary that August, "Our acoustic weapon has been neutralized by an unknown Allied countermeasure. We are effectively blind again. The strategic significance went beyond just sinking fewer ships. Britain needed 800,000 tons of supplies per month to survive. In the first 4 months of 1943, German submarines had reduced that to barely 600,000 tons. By September, with Bentley's devices in widespread use, monthly tonnage exceeded 900,000. Britain didn't just survive, it began stockpiling for the invasion of Europe. D-Day would have been impossible without those supplies. Impossible without the fuel, ammunition, vehicles, and food that crossed the Atlantic in convoys protected by a toy designer's spinning gyroscopes. General Dwight Eisenhower was briefed on the countermeasure in July 1943. His response, according to his aide's notes, was simply, "Who invented this?" When told it was a civilian toy maker, Eisenhower reportedly said, "Promote him, or give him a medal, or both." Winston Churchill, always attentive to the Battle of the Atlantic, received a demonstration during a visit to the fleet in August. He watched a recovered German torpedo that had been destabilized by the device and remarked, "Ingenious. I should like to meet the man who thought of this." The innovation changed doctrine for anti-submarine warfare. For the first time, navies realized that countering a weapon didn't always mean building something more powerful. Sometimes it meant understanding the weapon's physics better than its creators did. The principle behind Bentley's device, using an enemy's guidance system against itself, became foundational to electronic warfare and countermeasure design for decades. The Germans never figured out exactly what was happening. They knew their torpedoes were failing, but they couldn't recover enough intact weapons to reverse engineer the countermeasure. They tried redesigning the acoustic sensors, which made the torpedoes more expensive and only marginally more effective. They tried different propeller configurations, which reduced speed and range. By late 1944, they'd largely abandoned acoustic guidance for their torpedoes, reverting to straight-running weapons that were far easier to evade. The numbers tell the story. From September 1942 to May 1943, German acoustic torpedoes sank 117 Allied vessels. From June 1943 to May 1944, after Bentley's countermeasure was deployed, that number dropped to 23. Same ocean, same convoys, same U-boats, but the Predator had lost its edge. Max Bentley received the Naval Distinguished Public Service Award in a quiet ceremony in November 1943. He didn't want a ceremony at all. When asked by a reporter how he'd invented the device, he said, "I didn't invent anything new. I just applied what I already knew about balance and spin. Any good toy designer could have done the same thing." But that wasn't true. Hundreds of engineers with advanced degrees had looked at the acoustic torpedo problem. They'd approached it with sophisticated theories and complex solutions. Bentley approached it like a man who'd spent his career making sure toy trains didn't fall off tracks. He understood, in a way the credentialed engineers didn't, that sometimes the solution isn't about building something smarter than your enemy. It's about making your enemy's smart weapon stupid. After the war, Bentley returned to Lionel. He helped design the post-war line of electric trains that became classics. He rarely talked about his wartime work. When people asked, he'd deflect. "I made toys before the war. I made toys after the war. For a little while in between, I made something else. But I was really still just a toy maker." In 1958, a young naval officer was researching the history of anti-submarine warfare for his master's thesis. He tracked Bentley down to his home in Connecticut and asked him about the acoustic countermeasure. Bentley, now 63 and retired, sat in his workshop surrounded by model trains and toy prototypes. "You want to know the secret?" he said. "The secret is nobody listened to the toy makers. We understood spin and balance and momentum because we had to. A toy that doesn't work gets returned. A toy that falls apart gets the company sued. We couldn't hide behind theory. We had to make things work in the real world, in the hands of kids who didn't read instruction manuals and didn't care about our engineering assumptions." The officer asked if he felt proud of what he'd accomplished. Bentley thought for a long moment. "I'm proud we saved lives," he said. "But I'm not special. I was just a guy who made toys and happened to see a problem from a different angle. What bothers me is how many other people like me are out there, people with practical knowledge and unconventional training, and nobody asks them for help because they don't have the right credentials. How many problems could we solve if we stopped worrying so much about who has the degrees and started listening to who has the experience?" Max Bentley died in 1971 at age 76. His obituary in the New York Times was 3 paragraphs long. It mentioned his work at Lionel and briefly noted his wartime consulting for the Navy, but it didn't explain what he'd actually done. Most people at his funeral had no idea he'd changed the course of the Battle of the Atlantic, but the Navy remembered. In 1989, when the Naval Undersea Warfare Center opened a museum dedicated to anti-submarine warfare, they gave an entire room to acoustic countermeasures. At the center was one of Bentley's original devices, recovered from a storage depot and restored. The plaque reads, "The AN/SLQ-25 acoustic countermeasure, developed by civilian consultant Maxwell Bentley, 1943. Using principles of gyroscopic mechanics adapted from toy design, this device neutralized the German acoustic torpedo threat and altered the outcome of the Battle of the Atlantic. Cost per unit, $8.50. Lives saved, incalculable." In 2003, a German military historian named Klaus Weber was researching U-boat operations for a documentary. He interviewed former submarine commanders and reviewed classified records that had been sealed for decades. In one report from Dönitz to Hitler, dated October 1943, he found this line: "The enemy has deployed an unknown countermeasure of devastating simplicity. Our engineers cannot determine its mechanism, but its effectiveness has rendered our acoustic weapons nearly obsolete." Weber tracked down the Allied response and eventually learned about Bentley. His reaction, recorded in the documentary, was simply, "A toy maker. They were beaten by a toy maker." Sometimes the person who sees the solution is the one nobody thinks to ask. Germany's biggest secret wasn't the acoustic torpedo. It was the vulnerability hidden in its own sophistication, the assumption that advanced engineering couldn't be countered by simple mechanics. And one toy designer from Connecticut exposed it. Not with a laboratory full of scientists, not with millions in funding, but with gyroscopes from children's trains, a notebook full of sketches, and the kind of practical knowledge that comes from 20 years of making things that spin, balance, and absolutely have to work. The war was won by many heroes, but some of the most important never wore uniforms, never fired a shot, and never asked for recognition. They were the unlikely problem solvers who saw what others missed, who brought unconventional wisdom to impossible challenges, and who proved that sometimes the right answer comes from the most unexpected places. Max Bentley was one of those heroes, and his story deserves to be remembered.